So let's start implementing our non-preemptive scheduler. So in the previous video, I had shown you how to configure timer 3 peripheral to generate the necessary ticks, which will invoke our scheduler. So let's define a header file called non-preemptive scheduler.h where we are going to add the necessary include files as well as we are going to define a macro which will tell the total number of tasks which we have right now, which is 3, and we define a structure called task properties. Okay, so what does this task property contain is mainly the periodicity, that means how frequently the task should run, then a metadata called elapsed time which will help to keep track when the task was run, and then a function pointer to the task function itself. And then we are going to define an array n task whose size is defined by this macro total number of tasks, and three important functions. One is a non-preemptive scheduler. So this function will be called from our interrupt routine. Then set timer period, and we are going to use this function to program our timer 3 peripheral to generate ticks. Then a simple start timer API to start our timer. Let's make entries to this nTask function. So in my main, I am going to define three functions. So as you can see that I have defined my total task macro to be 3. So I'm going to define three tasks. So the first task whose periodicity is set to 1000, that means the task must be called every 1000 milliseconds. And I'm initializing its task function pointer with the function task1. Similarly, task 2, whose periodicity is 500 milliseconds, and I have given task 2 function pointer to task function pointer of its respective index. Then third task periodicity is 100 milliseconds, and I have given task 3 as its task function pointer. Now what is this calculated task period GCD? We are calculating GCD of the periodicities of all the tasks. So this will help us to configure our timer to generate interrupts at required periods. Okay, so these are all tool generated functions. I'm not going to touch them. And then we are going to call set timer period with the calculated task periods GCD, and then we are going to start a timer. Okay, now what happens in these functions? So start timer is pretty straightforward. So it is going to call the API which will start our configured timer 3. Okay. Set timer period will reinitialize the timer 3, except this time it is going to set the period with our calculated GCD. Okay. That means in our example here, we have set the GCD as 100. Okay. And what happens here is that this 100 is passed to this structure which is used internally by this API to configure timer 3 to generate interrupts at every 100 milliseconds. So this is our preemptive scheduler function which is called from our timer 3 interrupt handler. That means so whatever time period we have set, for example in our case it is 100 milliseconds, so every 100 milliseconds this timer interrupt is generated, and in the ISR we are going to call this non-preemptive scheduler function. So what does this non-preemptive scheduler function do? So as you can see that it simply iterates over all the elements of n task array. So here it is going to see whether for a given task whether the elapsed time has crossed the intended periodicity for that task. If so, then it is going to call the task function and reset back the elapsed time to 0. Okay. And subsequently what happens is in order to ensure that the task function is called periodically. So we are going to add this periodicity GCD to the elapsed time. So in non-preemptive scheduler function, you can see that it simply iterates over this n task array. Okay, and for each element of n task, it is going to check whether the elapsed time is greater than or equal to periodicity. Okay, that means whether the conditions are right to call the task functions. If so it is going to straight away call the task function and reset back the elapsed time to 0 so that we can add the periodicity GCD to it. If this condition is not true, that means the time has not yet come to call the task function. So what it does is it simply increments the elapsed time with whatever GCD we have calculated. Okay, and this happens when the timer interrupt is generated. As you would have already guessed by looking at this loop is that the task present at the lowest index is given the higher priority. Okay, that means this check happens first for the task present at the lowest index. If the lowest index task is not ready, then automatically it proceeds to next index and checks whether the next task is ready. If so, then it is going to call that particular task function. So let us download and run. So one more thing to note is that I have configured PC9 and PC8 to be a GPIO outputs, and I have connected an LED to these individual pins. Okay, so each LED pin is toggled by task functions along with an onboard LED. Okay, the same thing showing it here. So here I went to the configuration and you can see PC8 I'm setting it to GPI output and I have given it a name as task1 LED and PC9 as output and I've given the name as task2 LED and PA5 which is already the onboard LED I'm using it for my third task function. So post generation of the code you can see that it has generated the necessary macros which we are going to use in our task functions. So here are my task functions where each task function is printing a test string as well as it is toggling a GPIO pin. For example, in task 1, you can see it is printing hello from task 1 and it is toggling the GPIO pin PC8. Similarly, task 2 PC9 and task 3 is an onboard LED. Just to recap our task periodicity, so task 1 will be called every 1000 milliseconds, task 2 will be called every 500 milliseconds, and task 3 will be called every 100 milliseconds. So let's run this program. And here you can see that it is printing the text string from individual task. As you can see that each task it is running to completion. Okay, whenever a task function is called, it has to complete its execution and then return back. Okay, if it has to wait for any IO operations to happen, then appropriate logic must be implemented in these task functions so that other tasks could run. Now what happens if some task has, let's say for example, while one loop? Okay, what will happen? Let's build and see. So what happens is that my scheduler is stuck here. Okay, so it's not necessary that you are going to code a while one. Let's say because of some buggy implementation you encounter an infinite loop. So this gives our next topic, which is using a watchdog timer. See you in next video. So this concludes our implementation of a simplest scheduler. If you have any questions, please do drop them in the comment box below, and please do like, share and subscribe to my channel. Thank you.